equation twice, one for female, the other time for male. So here I show you that. Here if x equals 0, if x2 equals 0, you see x2 is a dummy variable, is 0. If it's 0, you see this part is beta 2 x2 or b2 x2 or beta 3 x1 x2 would go away. Okay, because these are become 0. So that's the equation here. This is the equation, we call it regression equation for female. Now, if I put x2 equals 1, so I have beta 0 plus beta 2 because this is 1. So I just put them together as a constant. And then we have beta 1 x1 and beta 3 x1. Remember, x2 becomes 1. So again, I factor it like that. I put the x1 and beta 1, beta 3. So this equation, regression equation for male. Here there are three scenarios we can talk about. One, if the two lines are parallel. Parallel means the rate of change in blood pressure between male and female are the same. In other words, their blood pressure goes the same rate. So if this is the case, so this beta 3 should be 0 because they should have the same slope. Beta 1 x1 should be beta 1 x1. So the two lines are parallel when they have the same slope or equal slope. So again, what is beta 3? Beta 3 is the coefficient of this interaction. So in other words, there should not be any interaction between age and gender in order to achieve that. Now, if the two lines start at the same point, in other words, the constant are the same, the intercept is the same, so this beta 2 should be 0. Beta 2 should be 0. Or if the two lines are coincident or coincide, means beta 2 and beta 3 should be 0. In other words, all the two lines becomes like that. Two lines become beta 0 plus b1 x1. So b2 and beta 3 should be 0. In other words, in blood, when it comes to blood pressure study, gender has no effect on that. Only age is a factor, something like that. Okay, that's a single equation model. And through this single equation model, we can separate the two lines. Let's do this empirically by the number. So go back to the SPSS data set. So we have to generate another variable here, and we call this variable interaction between age and sex. And here I click on analyze, not analyze, I'm sorry, click on transform, and then compute variable. And this time I have to come up with a new name for that interaction. In the note I have int, but a better name is age sex. Okay, like that, age sex. So I click on age, you see it goes to the right, move it to the right. And then I click on this asterisk here, which is time, and then highlight sex and move it to the right. So the product of these two variables makes an interaction. That's the way we define interaction in regression. And then I click OK. Then see a new column shows up here. So for for male subjects, you have numbers because you see 41 times 1 is 41, 60 times 1 is 60. But for female, everything is 0. Every entry in that column is 0 because that dummy variable is 0. So in other words, 39 times 0 is 0, 45 times 0, 0, and so forth. Again, I don't need that two decimals, and I like to move the data to the right and find out what type of variable it is. So I just click on variable view, and here I move the decimal to 0 and put this variable in the center and leave it the way it is as a scale. It's a scale is fine, it's a continuous. So I go back to the data view. You see you have that very good looking interaction column here. Now I'm ready to run that multiple regression equation. Consists of systolic blood pressure as a dependent variable, age, sex, and this interaction as independent variable. So I click on analyze, and this time I click on regression, linear. So systolic blood pressure is fine as a dependent variable. Age is as independent variable is fine. I move sex and interaction also as other independent variables. So we have 3 independent variables here. I have to remove that selection variable. So highlight that and click on that arrow, it's gone. So I'm ready to run that multiple regression by clicking on that OK. And that gives me the output. Again, I'm going to delete these, only concentrate on the coefficient table. Okay, in that coefficient table, you see we have the age, sex, and then interaction between the two. And as you see here, age is significant, and gender is not, almost significant, is not. If it's 0.05 or less would be significant, and the interaction is not significant at all. So in other words, that 1 point difference in the slope between male and female is not statistically significant. So in other words, we can say the rate of increase in blood pressure between male and female are almost the same. All right. So that's the idea here in this